You can hear me now. Yeah, okay. First of all, I want to thank you all for coming to this open lecture. It is my honor to invite Mr. David Kusuma in our university, dear rector, dear vice rector, deans, academic staff, and most importantly, students. We are honored to have you here and to be present at this open lecture that will be presented by the now past president of the World Design Organization. We are delighted that we are able to host Mr. David Kusuma at IBU, now as we are members of World Design Organization. Before I invite the speakers, I would like to use the opportunity to mention and thank the organizing team that made this organizing possible, and that made for Mr. David Kusuma and all this lecture to be possible, and that is the Vice Rector Mevludin Ibish, the Dean of the Faculty of Engineering Delcho Leshkovsky, Professor Maria Milosevskaya-Yanakieska from the Department of Architecture, and Assistant Adresha Ibrahimi and myself from the Department of Architecture. Again, thank you all for coming. I hope you will enjoy and you will learn something from this lecture. And first, I would like to invite Vice Rector Mevludin Ibish for a short speech. Thank you.
Thank you very much. It's a great pleasure to be here in front of you. Dear Rector, thank you so much. I think I need to use this one. I believe so. Thank you. Dear Rector, dear Ms. Kusuma, dear deans, professors, the president of the Chamber of Architects, dear valuable students. I won't hold you long, but it's just a presentation in order to speak volume that the presence of David Kusuma here at IBU. It's profound for IBU, but also it speaks volumes for the interconnection that IBU is holding with very important organizations such as the WDO. It's a great honor also to speak about the ideas that we are trying to build networks through our professors, which are intrinsically involved into these connections. We are delighted to be the first member of WDO in the Western Balkans, but also Balkan Peninsula, as I do know. Therefore, we are not going to be very passive actors. We are going to be very active in creating bridges, not only for professors, for the academicians, but also for valuable students to interconnect themselves with important companies that will be able to get skills and competences and help the companies to change the world with regard to the design. As I'm coming from political science, I know nothing about design, but I know one thing is that whatever we do, whatever we think, it's all reflecting in design, starting from architecture to branding and other services. Therefore, I truly believe that this moment is a stepstone to create new innovative forms of thinking, but also reflecting in terms of branding, specifically in times of hyperproduction. We create lots of products, but we have huge competition and competitiveness in terms of how the brand should look, but also in terms of architecture. Therefore, I believe that the Faculty of Art and Design and the Faculty of Engineering, together blended, could create an enormous opportunity for our students and for the IBU itself. Dear Kusuma, know the fact that IBU will be always open for you and for your organization, and let this be only the beginning of our cooperation. Thank you very much.
Now, before I release the stage to Mr. David Kusuma, I would like to just give you a short information and background for who actually we have as a guest today. So David Kusuma is a distinguished person in the innovation and products domain. Some background of his educational, a very strong and very reputable education background that is that he has a degree in mechanical engineering from the University of Pittsburgh, a degree in industrial design from Carnegie Mellon University in America, master's degree in business administration from Tilburg University in Holland, master's degree in management from Purdue University in America, as well as a PhD in philosophy in polymer engineering from Cranfield University in the United States. Besides the background, the extensive background that Mr. David has in education, he also has practical experience in reputable companies such as General Electric, Tupperware, Oregon Tool, and now, as of past, World Design Organization. It is my true honor and pleasure to invite a true pioneer to the stage, Mr. David Kusuma. The floor is yours.
So good afternoon, everyone. So I'm very honored and I'm pleased to be here. I'm going to give my presentation really in two parts. First, I want to give a little bit of an update on the WDO, the World Design Organization, and then I'm going to talk about the topic, the new materials and technologies to maximize user benefit. So you'll see a little bit of the process that we have used in the past in order to get to very human-centric solutions, some of them which are non-obvious. You know, that is always the objective. So let's start with the first slide. Okay, so about WDO. Sorry, second slide then. So the World Design Organization, it's actually the oldest global design organization in the world. It has its roots started back in 1957 as ICSID, the International Council of Societies of Industrial Design. And then 60 years later, in 2017, it was changed to the World Design Organization because it ended up with a more broader mission. The mission to design for a better world. You know, so now we connect with human communities around the world specifically to look at how design can help to improve the quality of life of people around the world and to help with things like social improvement, you know, not just products, not just services, not just experiences, but really trying to look at how to improve the human condition. Those of you who have been following a lot of the design work around the world, you know, the global design community will probably know about the UN SDGs, the United Nations Sustainable Development Goals. So if you don't know about these, I would suggest, you know, for you to look them up. You know, these are the objectives of the United Nations in order to solve the majority of sustainable issues around the world, but they really connect with everything related to quality of life in different countries and different communities around the world. It talks about things like hunger. You know, they have an objective for zero hunger. They have an objective for no poverty. You know, some of them are very ambitious, but you know, it's good that UN has these goals. They are officially called the UN SDGs, meaning Sustainable Development Goals. But the design community likes to call them the Sustainable Design Goals. So let's go to the next one. So this is our mission for WDO as the international voice for design. We advocate, we promote, and we share knowledge of design-driven innovation that has the power to create a better world. So everything is summarized in 5 words. We focus on design for a better world. Next slide. And these are our membership pillars. Individuals cannot be members of WDO, only organizations can. This is why IBU is now a member in the educational pillar category. But we also have professional design associations around the world. Normally when you are a professional designer, you would belong to an association of your national country, and then that association would become a member of WDO. We also have promotional organizations. Some of you may have followed some of the design awards that are being given around the world. Things like the Red Dot Award, IF Design, German Design Council. You know, there are quite a number of them. they fit in the promotional category because they use design to promote products and really the good use of products around the world. I had mentioned education. We also have corporate members, design forward companies like BMW, like Samsung, LG, a lot of companies that are focused on using design as a strategic advantage in their own philosophy in the products that they are trying to develop and trying to launch. And then finally, we also have cities and municipalities. A lot of our work today is focused on working with local governments because we look again at utilizing design to solve for quality of life in different human communities. So that would not be possible without working directly with the mayor's offices and directly with the cities involved. So the interesting thing is that cities can also become a member of the World Design Organization so long as they have a design department. If they have a design department, normally it's focused on urban design or city planning, they are eligible to apply for membership in the WDO. These are some of our global partners. We've had UN consultative status since 1974. So this means that we've been a recognized NGO of the United Nations since the 1970s. We've worked with a number of different UN agencies throughout the years. Some of the more interesting ones, for example, would be UNIDO. This is the United Nations Industrial Development Organization, UNIDO. Very close to industrial design, for example, because this organization actually also looks at how do we raise quality of life specifically by raising industrial capacity and capability in different countries around the world. So we've started this type of relationship so that we work on different projects with UNIDO, also with UN Habitat. We've had projects with the ISS, the International Space Station, with WPO, World Packaging Organization, SPE, Society of Plastics Engineers, Ellen MacArthur Foundation. They do a lot of work in sustainability. UCLG Africa, United Cities and Local Governments of Africa. It puts us in contact with, I think it's over 10,000 mayors from all of the prominent cities on the continent of Africa. The World Trade Organization is something that we want to start really getting involved with because the WTO is focused not only on commerce and business aspects, they're also focused on things like intellectual property, which we're really, really interested in. We've started a WDO Foundation. We have really great partnerships with Cumulus, also another global organization, but in the education sector. So we do joint projects with Cumulus as well. BETA, this is the Bureau of European Design Associations. We're really connected with them as well. University of Brighton actually holds the archives of the WDO. So for the 65 years that WDO has been in operation, all of the archives that are at the University of Brighton. And then finally, DOMUS. We have a new publication. Most of you who are in architecture especially probably have heard about DOMUS. DOMUS magazine, it's the most famous architecture and design magazine in the world. So now we have started a new publication called World Design. It's a publication by WDO and DOMUS to talk about leading edge issues with regards to design. Okay, so some quick opportunities for IBU, because it was mentioned that IBU is a member of the World Design Organization. So it's really important that you know about these opportunities. Let's go to the next slide. First of all, these are some of the events around the world that we engage in. And these would be open to you as well if you have interest. You know, a lot of them have to do with design weeks, they have to do with conferences, they have to do with workshops, and they have to do also with design awards as well. You know, so if any of them interest you, you know, you can see all over the place. Berlin Design Week, there are events in Australia, there's events in really throughout just about every part of the world. It's not even a full list, by the way. This is probably about half of what we actually engage in, but these are the most common ones that we see every year. Okay, next. Can we go back one? Okay, so there's also a Young Design Circle, which is really important because one of the missions is to nurture younger designers. When we talk about, designers that will take responsible positions in industry and eventually will lead the design profession. So there is a cohort. It's a little bit competitive because they don't accept too many people from one part of the world. The whole point is to create a network of young professional designers to work on issues that are also focused on UN SDGs and improvement of quality of life. Let's go to the next one. This is the publication with Domus. Our first issue was actually published already last month. The next issue is for April. So I think connecting with your faculty, for example, could be a good opportunity because they are going to be looking for different viewpoints on different aspects of design. So April would be kind of the next thing to kind of keep track of for the next issue. Let's go to the next one. There are 2 world design capitals that are really in play today. So there's a whole network of design cities. The one last year we were in Valencia, Spain. Next year we are in San Diego, Tijuana. Super interesting design project that they have. These are 2 sister cities on both sides of the US-Mexico border. And then they are focusing on issues like human migration. They're focusing on issues like homelessness, and design's going to be playing a big part in trying to find solutions. I think what really excites me is that any solution that actually comes up, it's transportable. You can take it to other parts of the world, right? Because if you actually look at the root cause of why large numbers of people migrate at the same time, there are only a few of them. It's either political persecution, or it's economic strife, or it's natural disasters like earthquakes. So you could always transport the solutions that you come up with to other places that have the same kind of issues. And then World Design Capital 2026 has already been announced. It's much closer to Skopje because it's in Frankfurt. And these are all opportunities, to get involved with some of these projects. I think they're going to be talking about the issues related to democracy and how design can play a role in the strengthening of democracy. Next slide. We also have World Design Protopolis. We signed an agreement with the government of the state of Karnataka in India to look at how do we fix the infrastructure in the city of Bangalore, which is the capital of Karnataka. So this is also an opportunity because they're also accepting proposals as well. Bangalore is a city that is considered the Silicon Valley of India. It's their hub of innovation, it's their hub of technology, and really, the focus for them is how do they use design to improve the infrastructure that hasn't kept up with the population that has moved there. Lots of interesting opportunities for design and architecture to get involved. Let's go to the next one. Global design competitions. I had mentioned our promotional organizations, but global design competitions, I think these are really great for designers or let's say design students and students of architecture as well. This is a project that only was juried about a month ago. I was on the jury of this competition in Shang'an, China. And one of the winning projects was an architectural vision of changing electrical, I don't know what you call it. There are these electrical distribution centers, that have a lot of wires that normally come into them. And these are areas where people normally cannot enter. And And their concept was, how about if we put most of that infrastructure underground, put some shielding over it, and actually build parks so that the land is accessible. Really interesting concepts, moving forward. So these are opportunities for students as well. And then we finally, the World Design Impact Prize. We don't give product awards because those are left to our members in the promotional category, but we do give one project that has the highest impact on quality of life. And I'm using this as an example, but this was one that was entered in 2016, one of the winners, Warka Water. It is for regions in Africa where there is basically desert and there's not a lot of water. So these sculptures actually wick water out of the air, and it also collects rainwater. So it gives local communities access to water where they normally wouldn't have it. And so this one actually won the World Design Impact Prize back then. It's one of my favorite applications. The interesting thing is that because we are a UN NGO, we can go in front of the General Assembly. And our idea is to bring winners of this World Design Impact Prize in front of governments that are represented around the world to show that design can actually have an impact on quality of life and on social improvement. Okay, so I want to now go into the main topic. A lot of what I'm going to show you is during the work that my team did when I was head of product at Tupperware. I used to be vice president of R&D and product development at Tupperware. And a lot of our emphasis was on how do we create really game-changing products from ideas that haven't existed, and how can we take much bigger risks, much bigger leaps of innovation. So let's go to the next one. So the first part I want to talk about is understanding innovation. And this is really, really important because a lot of people have different definitions of innovation. And I've been really privileged because in my position, I've actually sat on a number of corporate boards, and a lot of the information that we actually exchange have to do with innovation and how companies use innovation in order to further their missions. So let's go to the next slide. Next one. Okay. So the first topic that we have been discussing is that all companies fear disruption. And this is absolutely true. They have had a survey of corporate CEOs, and they found out that actually corporate CEOs have felt that 30% of their revenue of their company is at risk because of disruptions. And I would say that probably today, it's more like 100%, because if you don't continue to reinvent yourself, someone else could come and take your business. Let's go to the next. Oh, okay. So here is a picture from the CES. Have any of you been to the CES, the Consumer Electronics Show in Las Vegas? The largest consumer electronics show in the world. And it's actually always during the first week of January, because they want to be the first. But they are showing 3D printing. 3D printing, of course, is a disruptive technology, but they're showing it here for food. So 3D printing is disrupting not just the plastics industry, but it's disrupting all these other industries, that we take for granted. They were 3D printing cookies. I actually had a chance to taste one. Tasted like cookies, but just the fact that they are using this methodology for mass production, I think is just amazing. The industry, by the way, likes to shift. They don't want to be called 3D printing for prototyping. They actually want to talk about being additive manufacturing. They want to be known for production. Let's go to the next one. Okay, so what got, normally I show the title first and then I bring up the next thing, but it's okay. What got you here won't get you there, and this is really important because business plans that companies have, they don't last as long as they used to. everything is totally up for grabs by startups that have really nothing to lose. Okay, so go ahead and show this next one. These are companies that most of you are familiar with: Uber, Netflix, Dropbox, and so on. Even the Chinese ones down at the bottom. They can come in and they can take over businesses because, again, they have totally a different way of thinking. So it's important for companies not to look at only incremental innovation. They actually have to look at, bigger leaps. How do we get bigger steps of innovation into their work? Next one. Okay, and making innovation work. So another survey of corporate executives highlighted that 93% of corporate executives felt that the future success of their company really depended on innovation. The interesting thing is that only 1/5 of them, only 20% of them actually felt that they were doing innovation in a good way. So it's a big opportunity. Show the next one. So according to Business Week, it is the single most important business challenge of our era, is making innovation work. Okay, next one. Okay, and this is the final thought that I wanted to provide on this. Avoid linear thinking. The issue that most companies face is that if they have had success in doing things a certain way, they keep doing it the same way all the time, right? And it may have worked in the past, but today the reality is they have to expect the unexpected. It's not enough to think the same way because, we live in a non-linear world. You can't be always thinking in a linear way. So, the future is not a continuation of the past, right? So past success does not guarantee future success. So we talk a lot about these things. Let's go to the next one. I want to touch on consumer research because anyone who's developing products, consumer research is so incredibly critical. You have to understand who your audience is, who the consumer is that you're actually targeting your products for. So let's go. Our big focus was how do we enhance user experience and how do we maximize user benefits? And you can only do that if you actually get intimately involved and know your user. So let's go to the next one. Okay. So to be a little bit of an echo there. But anyway, what you saw is really a product that is multifunctional. It used to be that we focused on products that did one thing and did one thing well. But then, finally the company's focus was how do we actually provide maximum value to the consumer, to the user, so that the product that they buy actually can do several functions at once. Okay. Every area that we have presence in the world, we focus on creating an activity cycle, and this is really looking at the behavior of people, from the time that they wake up to the time that they have their lunch, they do other activities during the day, all the way until the evening, and it's all different for different areas of the world. But the key here is that we were looking specifically at trying to find the gaps. Where are the areas in people's lives that we can actually add value? So this is really what we were looking for. Let's go to the next one. Everything is focused on user research and consumer insights. We would map out everything in order to really come up with, what is the needs and the wants of the consumers we were looking to serve. A lot of trends comes from different areas. You can look at stores. We do a lot of store checks. We attend a lot of fairs. We go online, like probably most of you, and look at websites. We look through magazines. We attend exhibitions. But the whole point is to try to find trends that give us more information. So I want to share with you actually 4 mega trends that have really come up with regards to the housewares industry, and what is the most important to this segment of the population. Let's go. So the first one is healthy cooking and healthy eating. Probably most of you also fit into this category. What we found is that today, most people, they want to be healthy, but they want to be fit as well, and they want to eat healthy. They want to eat well, and I think this is really the key to to how people behave as they move forward. Let's go to the next one. The next one is home organization. So home organization, what we found is that many people, they love to get organized. The problem is most people, they don't know how to do it. And what we found is that, and again, this is using a lot of user research, showing that if they want to get organized, what we found in their garages and their basements was just a lot of junk, while their expensive cars were actually rusting in their driveways, for example. Next one, saving money, especially during times of economic downturn. People want more value for the money that they spend, for the euros that they spend. Okay, next one, and then going green. It's really important, especially to the younger population. They're looking to companies that they buy items from to make sure that these companies are more responsible to the environment and to the planet. And they're willing to spend more money if they have more green products. Okay, and everything is summarized into this whole concept of home. Home stands for health, organization, money, and the environment. And the idea is that if a consumer is looking for a solution in one of these categories, probably Tupperware has it for them. Okay. I want to cover design values. Probably most of you here are either in art or design or in architecture. You need to have design values. If you're going to be developing anything, services or products, you have to know what your products stand for, and you have to know what they represent. We have 3 design studios globally. Orlando in Florida was our main headquarters. Belgium was our design center for Europe. And then I opened up a design center in Singapore for Asia Pacific. So who designs Tupperware products? We actually had a whole diverse group of designers working on products. This is Vincent Jallet, one of our design managers, who is leading our design team in Europe. A lot of our designers, they take design very personally. Whenever we launch a product, they actually come and they insist on doing something special. Here you actually see them wearing their Tupperware during a launch program. And then the teams would all get together. That I think is not exclusive to design, but we had project teams specifically working on each of the products. And by the way, at Tupperware, we launched anywhere between 150 to 200 new products every year. So a lot of products. Next one. I want to talk a little bit about our design values, because this is really important. I had mentioned that you need to know what your products stand for. The first one is original thinking. And I love sharing this with people, especially designers, as they are looking to create their own philosophy. Original thinking means the idea has to be new. It cannot be a copy of what's already on the market. The second one is confidence. Confidence has to be that the product has to be doing what it was meant to do. You know, it has to do with a lot of trust building. The third one is desire. Anyone of you who have purchased Tupperware in the past know that this product is expensive. So, you know, our focus is how do we make this product so that it's desirable? How do we make this product so people love it? Honesty. So honesty has to do with the materials. You know, we talk about food safe, we talk about, you know, flexibility, we talk about things related to, you know, functionality as well. But the whole point here is that we are using the right materials for the actual functionality that we're looking for. Hint of surprise, this goes back to that whole focus on multifunctionality, which means that this product can do this, but it can do so much more. It can do other things as well. Sophisticated simplicity, the product can be simple, but it can still be elegant. Warm, inviting, and friendly, something that you want to touch, something that you want to own. And then quality. A lot of the products are actually purchased because they seemingly last forever. So we never sacrifice on quality. Next one. And we also focus on soft skills. You know, all of our designers were actually sent to cooking school. And this was really important because if you have people who are going to be developing products for the kitchen and for chefs, you know, for cooks, they probably need to know what they're doing. So, you know, that was a big part of our internal training. And we focus on everyday good design. You know, this is where we talk about, we don't design products to go into museums. Although we are very happy that a number of our products are permanent collections in different design museums around the world. But it's not why we develop the products. We actually develop the products because we want to provide the maximum benefit. We want the user to use the products every day, and in cases maybe multiple times per day, because, you know, the more often people use the products, the more value we know we're giving them. Next one. And the big thing is design for life. All of Tupperware is designed to last just about forever. If it fails, you can actually bring it back. They will take it back and they will replace it. Okay, a little bit on materials and R&D. Let's go to the next slide. This is our manufacturing footprint. We have plants in every part of the world, on every continent except for Antarctica. Keep going. Some of the technologies that Tupperware is really good at is in polymers and in polymer manufacturing, like injection molding. They have a lot of expertise in these areas. Next slide. Especially with regards to automation, and especially with regards to multi-component molding, where you mold different materials together. Next slide. Materials and material additives, you know, are really what our expertise is in this area. Keep going. We even developed a whole map in terms of, you know, how designers would specify their materials. If they're looking for high temperature, if they're looking for clarity or stiffness, or trying to resolve staining, or trying to find something affordable, you know, we can actually help them find the best solution based on what they're trying to do. And we work a lot with open innovation. You know, open innovation networks, especially when we're bringing in new technology. This is really important to build partnerships with other institutions, other universities, other organizations that can help extend our reach and help us to do things we couldn't do ourselves. So technology readiness levels, TRLs. I don't know whether any of you have heard of TRLs, but this is actually a system that was developed by NASA years ago. And the interesting thing is that, you know, it tells you the levels of technology readiness levels based on, you know, whether something is just emerging, like from the university, would be early TRLs. Then you have this mid-stage TRLs where you're actually looking at creating proof of concept from some of the early research. And then you have late-stage TRLs where the technology is almost completed, and then you can actually look to implement it. You can actually apply it. So next one. This one is the governance for R&D, because everything that you or that we had incorporated needs to lead back to the consumer, right? So every technology must touch base with value for the consumer. So very, very important. All right. Okay, so now I want to get into the case studies. These are interesting examples of the use of different technologies and really, kind of design methodologies. We have these serving bowls. Serving bowls are actually very boring. They're just bowls that sit on your table. But we created this effect similar to glass by using these different color pellets. The interesting thing was using color pellets that melted at different temperatures. It gave you the streaking effect, so that just like you were adding pigments to glass, you could actually create this effect. The interesting thing is that consumers, they really love this, but our operations team in manufacturing, they really hated it. And the reason why they hated it was because they are taught to make sure that each part coming out of a molding process are identical. And here, every part was unique because of the streaking process. Let's go to the next one. Another serving bowl. So this one was based on optics. I came from the automotive industry before I went to Tupperware when I worked for General Electric. And so I actually hired one of the optical engineers that I used to work with, but instead of designing headlamps, I asked him to help me design this serving bowl. And looking at the reflection and the refraction, so the refraction is the bending of light through the prisms. How can we maximize the amount of light through the part, and how can we reflect the maximum amount of color? So you can see that was what was accomplished. This thing ended up being a really big seller around the world just because of the effect of the prisms. Okay. I want to talk about microwaving technology because we did a huge amount of work in microwaving technology. Every one of you probably have a microwave oven either in your home where your parents are, or you have access to one here in the school. What we found is that most countries have a very deep penetration of microwaves, meaning that almost everyone has access to microwaves. But if you take a look at what people actually use them for, most microwave ovens are used primarily for reheating. So for us, this was a real opportunity. We could actually convert this appliance that everyone has into something that it actually cooks, that actually becomes a valuable cooking appliance. So let's go to the next one. So we created a couple different scenarios. This one was one of the simpler ones, but I wanted to show it to you because you know that there is a little bit of strange geometry in these products. It has this little hump on the bottom. We reflect the style of the design on the top. But the interesting thing is that a lot of people, they think that microwaves cook from the inside out, but they don't. They actually cook from the outside in as well. And if you take, in research, food like cupcakes, and you put them in a circular pattern, and you put one in the middle, what you find is that the outside, the perimeter, cooks faster than the inside. So if you're actually able to graph on a histogram, do a normal distribution in terms of the amount of doneness, the amount of cooking, you'll find that you cook a lot on the sides. It dips down in the middle and then back up on the sides again, because again, it cooks mostly around the perimeter first. So actually, by changing this geometry, and this is purely a design exercise, what we're doing is we're actually reducing the cross section of the food right in the middle where the cooking is the slowest. So this simple solution gives the consumer the ability to cook a casserole with completely even heating throughout the entire product. Let's go to the next one. Microwave steaming, this was also done for the microwave. We used a material here that actually reflects microwave energy, meaning that the microwaves cannot penetrate the main chamber that you put the food in. Really a game changer. I have to tell you that when I proposed this to senior management, they thought I was crazy, right? They said, how can you justify investing in a product for the microwave oven that doesn't allow microwaves to penetrate? Doesn't make any sense, and for our team, it made a lot of sense. Why? Because we're also trying to solve the issues that people had with regards to bad experiences. All of you who have used microwave ovens for reheating your food or even for cooking your food will have had bad experiences. Things like chicken that has turned into rubber, or breads that have become hard as stone. These are all the things that we were trying to avoid. How do we correct the bad experiences that everyone has? So this product actually has a reservoir on the bottom. It's a colander, so it has holes at the bottom, and it allows you to layer in your foods. The beauty of this product is that it cooks 100% by steam only, because it reflects the microwave energy. It doesn't cook at all using the microwave energy. So it really was a game changer. Became one of the top selling products in Europe, and it's still being sold today. Let's go to the next one. One of the big projects that we focused on was using metal in the microwave. I was always getting the question, I thought you cannot use metal in the microwave oven. And the answer is actually you can. You just need to use the right metal, and you need to make sure that you use the right geometry so that you stop sparking. Let's go to the next one. We developed a whole line of products with metals. We worked with the Fraunhofer Institute in Germany to actually come up with the right material and also the right application of the metal. The beauty of this one was that we actually utilized a special susceptor, they call it, metallic powder inside the high temperature silicone that actually converted electromagnetic energy inside them from the microwave oven into thermal energy that was used to cook the food. The interesting thing here, let's go to the next slide, is that we focus on one material property. The one material property is called the Curie temperature. The Curie temperature is the temperature where magnetic materials lose their magnetism, right? So basically what happens is that you have a very fast slope. You reach terminal temperature very fast, but once it goes beyond the Curie temperature, it loses its magnetism, and then basically the temperature drops. It goes below it, it reignites again, so the temperature through this oscillating wave actually can be controlled. And that's a benefit, because if you cannot control temperature, then any recipe you're trying to cook will not work. But if you can control temperature, the only other thing you need to control is time. And then you can repeat your food all the time. Okay, let's go. And really this was designed to cook all sorts of different foods. Let's go to the next one. We also launched a lot of recipes. Every product that we came up with, we had a whole set of recipes. Let's go to the next one. So each one kind of gave the consumer the idea in terms of how to use the product so that they weren't left guessing. Next one. food faster than your grill because it cooks from both sides at the same time. Next project that we focused on was a sustainability issue. You know, and sustainability is not only in the materials, it's also in how you use your product. In this case, we were looking at how do we reduce food. If we can make food last longer, it can give the consumer an additional benefit. Number one, they save on money. And the second one is that they save on the environment because, you know, a lot of methane gets put into the atmosphere in terms of greenhouse gases from spoiling food. And we follow the Global Footprint Network. You know, so this is an organization that basically tells you know, how well the world is doing, how well the Earth is doing. They measure the health of the Earth in terms of how fast and how able it is to regenerate itself. You know, so just like you're taking materials from the environment, like cutting down trees, you know, trees regrow, but you know, how does the world actually replenish its resources? And what they're saying is that we're actually behind. You know, we're behind the 8 ball, and the reason why is that you know, based on our current rate of depletion, by the year 2050, we will need 2.3 Earths to continue to sustain ourselves. So it's really important that we change our behaviors, because if we don't change our behaviors, what it means is that at some time or another, the world will start to experience great scarcity. Let's go. A lot of the work that we did in our R&D lab was based on real world problems. So here we know that 1.3 billion tons of food are wasted everywhere around the world every year. You know, in North America, 40% of all food is thrown away. So it's a huge amount considering the number of people who don't have access to good and nutritious food. Let's go. So we created a whole new food category called food conservation, you know, and we targeted a number of products specifically to try to solve this issue with regards to quality of food for a longer period of time. We came up with this product after working with a number of land-grant universities. So land-grant universities in the US are universities that the government gives a lot of money and a lot of land to for agricultural research. And what they did was they measured all of these different types of vegetables, fruits and vegetables that we all eat on a daily basis. And what they found was that you have to store fruits and vegetables as if they are living entities, because they are still living, which means that they have a respiration requirement that has to be fulfilled. You know, even after post-harvest, you still have to allow them to breathe. And this whole focus was on fruits and vegetables that had the high respiration rates, which we call high breathers. Then there were ones like berries that were with low respiration rates, low breathers, and then that whole area in between. You know, so all of the science actually ended up with the size of holes. You don't see the holes because they're under this sliding switch. You know, the user, depending on what they're putting into the product, can actually customize their experience because they're the ones who are putting the product, the food product into the container. Now, the interesting thing is that, you know, this was also a game changer, because when I presented it to senior management, the same thing happened. They thought I was crazy. This was a project that I proposed only after being 2 years at Tupperware. You know, I was their head of product for 20 years. So this one was short in my tenure. And they said, you know, for decades before you got here, we always told our customers that the best way to store food was in hermetically sealed containers. And suddenly you come along and you want to put holes in the containers. You know, so a totally different line of thinking. The key thing is that data doesn't lie. You know, I mean, this is all based on scientific research. Let's go to the next slide. You know, it allows the user to customize whatever they put into their container at their will. The user doesn't have to understand the technology. They just have to know that the product works. Let's go to the next one. This is a just by managing the whole for oxygen exchange and for moisture management. And we also did the same thing with cheeses. You know, European cheeses have high moisture, so very quickly they become unappetizing because the water evaporates, it condenses on the top, and it drips back down. So we solved this problem actually by using a special film. We worked a lot on the materials. We were focused on MVTR, the moisture vapor transmission rate. And you know, being able to dial that in so that you would be able to take all the excess moisture out of the container, but not too much, because we didn't want the cheese to dry out either. You know, it was a very close balance. Let's go to the next one. Yeah, so here we were just kind of like graphically showing it. The key here, you know, the beauty of this, any of you who work in engineering will understand the very simple physics principle. And basically what we're doing is we're moving vapor from an area of high vapor pressure to an area of low vapor pressure. And it's always the highest inside the container because that's where evaporation is taking place. I'm going to jump to some of our projects on space. So all of you know about NASA, of course. We also had a mission with NASA. Every mission that goes into space has a space patch. You know, so this was our space patch. It was designed by our design team as well. It was called PONS. PONS is a passive orbital nutrient delivery system. So what happened was NASA came to Tupperware and they said, based on your experience in food safe materials and based on your experience in food conservation, you know, we want you to work on this project with us. Astronauts in space, they are living longer and longer in orbit, even elapsing more than 1 year, right? And all of the food that they consume, you know, and I visited the space kitchen with my team, all of the food that they consume are freeze dried. So they're actually prepared in the space kitchen in Houston. They're sent to the point of launch, and then they're sent to the International Space Station. In fact, it's interesting. Whenever an astronaut gets a call to go into space, the first place that they visit is a space kitchen, because they want to get a menu of what the astronaut wants to eat. And then they have a group of food scientists that help to try to determine the recipes in order to get them the proper nutritional value. And from what I understand, it's really a faux pas. It's a no-no for an astronaut to eat another astronaut's meal when you're up in space. So because of that length of time, it became really important for astronauts to have access to fresh fruits and vegetables. So the idea was, how do we grow vegetables in space, in microgravity or in zero gravity? And you know, it's a very, very difficult design problem. Let's go to the next one. This is what we actually came up with. We actually solved it using 3 basic principles. One was on specialized geometry. You know, you can have sharp inner corners that want to hold water, and you have more generous curves that actually release water. The whole point here was, how do you channel water in space so that it's only at the place where the plant can actually draw from it, right? Because if you actually take the scenario of being on Earth, Earth has a gravity effect. So if you have a potted plant and you pour water into a potted plant, the water goes to the bottom and then everything follows natural order. The roots go down, the plant goes up. But in space, water wants to go everywhere. So how do you control that water? You know, that's a very big design problem. So again, specialized geometry was one. The second thing that we used was surface energy. You can increase surface energy that actually holds the water, or you can make very low energy and release water as well. And then the third one is capillary forces, capillary action can help to siphon water as well. So, you know, we built this. If any of you actually have interest in this project, all you have to do is go to your search engine and type in both Tupperware and NASA on the same line. It'll take you to our project, or you can go straight to the NASA website, and the NASA website features it as well. You know, they have this whole article in terms of how they're working with Tupperware to turn astronauts into space farmers, that sort of thing. Okay, let's go to the next one. Every time we launch a product, we always have this media event. We have to talk to the press and explain, the project and explain what's different about them, because it's so interesting. You cannot see it here, but every product that I sent to the International Space Station, and I've already done four flights already, are branded Tupperware. And NASA has always asked me, why do you brand things? That go to the space station. There aren't people up there, and we put stickers on them anyway because astronauts have to have instructions on how to use this thing. So my comment is, just let me do what I need to do, and you do what you need to do. And really the reason of branding it is very simple. Those of you who are remembering the Apollo missions to the moon, there's so many interesting photos that have come out of these Apollo missions. But what is the most famous one? Does anyone know? Which one? Flag. Okay, so the flag is definitely one of them. But actually the most important photo from that era was the first step on the moon. The first footprint of the man on the moon. And the company that actually worked with NASA to design the soles of those shoes was a company called 3M, and they forgot to put their logo on that shoe. Otherwise, everyone would have seen it. Okay, so let's go to the next one. With this project, I had access to a lot of NASA scientists and astronauts. Soichi Noguchi is a famous Japanese astronaut, and then Kate Rubins, molecular biologist. She's actually the first person, the first scientist to sequence DNA in orbit. Next slide. This is how they actually put them in terms of the configuration on the space station, and you can see they're all branded. Next one. This is actually a picture from the space station from Christina Koch, who was working the units up there. The interesting thing is that we actually got to be in the same room when the astronauts were working on our projects. We went to Kennedy Space Center. We saw them on the large screen. We weren't allowed to talk directly with them, but we could pass our questions along, and then the administrators forwarded our questions to the astronauts.
Tupperware has been locking in freshness since the mid-1900s, and it recently used its expertise on the subject to help develop a better way to grow vegetables in space. Astronauts aboard the International Space Station, or ISS, have been cultivating leafy greens to supplement their diets, but the current means has shown there's room for improvement. Issues with the growing system largely involve hydration. The watering means relies upon pillows that must be filled with a syringe, and unfortunately, not all plants have responded well to that method. Tupperware was consulted in the development of an alternative. NASA reports the new system requires less crew maintenance and uses absorbent mats that leverage the basic principles of surface tension and capillary action to wick water to seeds and roots through a reservoir system. This approach passively disperses water evenly through each plant cylinder contained within the reservoirs, facilitating consistent seed germination and seedling development into mature plants. 7 of the updated growing environments will be part of SpaceX's next ISS supply delivery.
So yeah, this was something that NASA had put out with the media during one of the launches. I want to show this last project to you, and this is about sustainability as well. I talked about how do we conserve food. This one focuses on conserving water. And again, when you're working on R&D, the whole point is you have to take big risks, and I'm going to show this to you. So again, we take our motivation from real world problems. 1.8 billion people live without access to clean water. So how do we utilize water in a more respectable way, in a more responsible way? Let's go to the next one. Story Musgrave. Again, living in Florida for Tupperware, I actually had access to a lot of resources that normal companies wouldn't have. Story Musgrave is a retired astronaut, a doctor of medicine, but also a doctor of biology. I hired him. He was only willing to work 1 day a week, but he would come into the office. And the project we gave him was water. How can we clean water in a very simple way? He's actually the most well-known for doing the spacewalk to fix the Hubble telescope. That was one of his missions. Let's go to the next one. That's how he looks today. But you can see in the back, his focus was on the personal water purification system that he worked on with us and for us. Let's go to the next one. This was the outcome, actually. He ended up bringing in a NASA technology that used a nanoceram wrap, basically a ceramic material that had nano-sized pores. The complexity of this project was that every market that we talked to wanted something different. Not just a log-6 reduction in bacteria, but they also wanted viruses, to be removed as well. The benefit of this technology is that just through geometry, just because of the nano-sized holes, they were able to remove all of these pathogens from the water without adding any chemicals. It was just taken out strictly mechanically, which is great. You have the water and you didn't have any chlorine or bromine in there. Let's go to the next one. Just a whole list of different functions. Let's go to the next one. Okay, so this is where we wanted to take our next leap. How do we really maximize the conservation of water? And one of the ways that we were thinking was in washing. A lot of countries still don't have dishwashers. So if you actually wash your Tupperware in running water, the issue is that you consume much more water. It says here 63 liters of water on average is used in one hand washing session. But if you actually let the water keep running, you could go well over 100 liters. So it's a huge use of water. Let's go to the next one. We focused on biomimicry. So biomimicry, looking at the lotus leaf. The lotus leaf is the most super hydrophobic material in nature, which means that it repels water the most efficient, right? And if you take a look at this blown up section over here, it's actually a micro nanostructure, and you need both of them in order to solve this problem. But you can see the water droplets on this. Let's go to the next one. So here what we did was we tried to mimic the lotus leaf. And we're measuring contact angle. So the contact angle actually measures the sphere of the drop. The more perfect the sphere is, the higher the contact angle, which means that it's more super hydrophobic. It repels the water more efficiently. For us, we actually had another problem because it wasn't just water. We wanted to repel oils as well. How do you, cooked food has a lot of oil. Our big mission in this project was how do we design Tupperware so that it has a surface that never gets dirty, and so you never need to wash it because all of the dirt on the inside just comes clean. Sounds a little bit science fiction-y, but if you're going to be doing R&D, you accept some of these premises to try to solve. How do you make Tupperware that never needs to be washed? So you can see that if you look at the size of the spheres, the maximum contact angle that you can achieve is 180 degrees, right? So that's exactly the surface from one side of the angle to the other. That'll give you a perfect sphere. The lotus leaf is almost perfect. It's 170 degrees. And I'm going to give you a frame of reference because all of you have used nonstick cookware. Nonstick cookware is only 90 degrees. So, how do you bridge the 90 degrees all the way, to like 170 degrees in order to maximize this hydrophobic effect? Let's go to the next one. So we were actually able to do a whole combination of technologies. I cannot share that with you because it's still proprietary for Tupperware, but they were able to achieve in our laboratory 150 degrees. So a lot more than Teflon, but still less than the Lotus effect. But you can imagine the possibilities, like glue that doesn't stick, or honey. If you use like an implement for honey, and then after you use your implement, you don't have to clean it because the honey just runs clean, right? I mean, really, it sounds like science fiction, but it's all science-based. Or sticky substances, like in bottles. You don't see the sticky substances on the side because everything comes down. So let's go to the next one. Okay, don't hit the thing yet. Actually, you can hit the next one. But so what we did was we actually created this Lotus effect using biomimicry and different technologies. We used surface treatments, we used mold textures, and we also used additives. One was untreated and one was with the Lotus effect. We colored the exactly the same material, by the way. This is a type of polypropylene that we used. The difference was that we wanted to know which was which. So the untreated, we colored red. The Lotus treated one, we colored a little bit blue. So this just shows you with on the untreated one. But the one with the Lotus effect, it just rolls right off, right? So go to the next one, and you can see we did a whole bunch of other experiments to show that you can actually get this effect and end up with products that actually you never need to wash because they never get dirty. Next one. Just ending with a couple quotes. So a modern future, right? It cannot live without materials and technologies, but we do need to be, especially as designers, to be responsible, make sure that we use them in a sustainable way so that the next generation can still have materials and resources. And then the most important quote that we used to believe in, next one, is that tomorrow is always more important than today. Thank you. Do we want to take questions? Oh, okay, please. Mm-hmm. So what you're talking about is a fluoropolymer, typically known as like Teflon, for example, that have PFOAs. They have actually bad chemicals that are utilized to create that final material. So this is not like that at all. This is not a fluoropolymer. I can't tell you too much, but what I will tell you is that it has a slight glass coating on top of the polymer. And the glass coating has a certain textural quality that actually helps to solve that issue. Yeah, please. Mm-hmm.
products to make consumers just constantly get like dopamine effect and want new products? And how can we make it so one product can sustain longer and not make a new product for the same thing?
So I would say excellent question. Generally speaking, first of all, I would say that Tupperware is designed to last forever, right? I mean, it's not meant to be a limited use product. You know, it's not like packaging materials where you would buy food on the go, for example, take out the package and then throw it away, and it has a limited life. It's meant to be used again as many times per day as possible, and it's meant to meet the requirements of the functionality. You know, I will tell you that I've talked at quite a number of conferences. There was one that I spoke at in which the person speaking before me said, never use plastic, totally bad for the environment. You know, I was following him, so I was thinking, now what do I say? But, you know, so I went up and I said, okay, I disagree with this gentleman only because the material is actually a great material. It's probably the most flexible material. It is the most design-friendly material because you can put it in any shape that you want, and it has a full range of properties that other materials don't have, right? So don't hate the material, but hate the bad use, because definitely we have people who are using the material in a way that ends up putting microplastics in the ocean and that sort of thing. So, you know, I think it's a balance, and I think designers have that responsibility to make sure that whatever material that they're using has sustainable considerations, whether it happens to be reuse and recycling, because you're right, if you have too many different types of material, not so easy to recycle, right? But you know, it's both that, and it's also longevity. If you actually design something to last, people won't throw it away, because you know, there are lots of stories of Tupperware where people go to family reunions, for example, then they take away food, and when they take away food, the hosts, the parents, they want their Tupperware back. You know, so it's like, give me my stuff back. You know, versus using other stuff that you buy in the supermarket that you don't really care whether it comes back or not.
Okay, thank you. That was my question.
Yeah.
Thank you so much.
Thanks.
So I actually have a question. So previously you mentioned that when you started your work at Tupperware, you said that in your first 2 years, like, you came up with a new concept about the humid boxes, about the vegetables, their longevity. So like, in your first 2 years, you blew the whole narrative of what the CEO, I think, said, that for the last 30 years, they said to their customers that repetitively that they need to use, like, in their vegetables, to store them in hermetically closed boxes. So that's one narrative that you, like, disrupted and blew, like, you came up with a new innovation. What about the other strategies that, for example, this company, Tupperware, uses for, like, long periods of time, for like 30, 20 years, and then realized that actually that was the wrong decision to make, that was the wrong method to be using? What about these kind of strategies? Like, when you, for example, came up with a new concept, like, do you keep, like, testing those concepts and stuff, or do you, like, get a new concept, see that this concept is better, and, like, stick to it for the next 30 years? Or do you just, like, keep trying and improving and stuff? Because it has it has a negative effect, because that using, like, hermetically closed boxes from your company, for example, that did contribute in the issue that you were trying to solve, like, for example, the waste of the food. So, like, do you keep testing the strategies or the concepts that you make?
So also a good question. The issue is that things always change when you learn new things, you know. And when I joined Tupperware, the big focus on sustainability was in recycling. I mean, most companies do that, and that's fine, but there are ways to be more sustainable also in terms of human behavior, right? One of the teams that I led in product development was also a team focused on life cycle assessments. Are you familiar with this? life cycle assessments is basically the calculation of your carbon footprint and your energy footprint, and basically how much resources you actually utilize. So because of that, I started to put more emphasis in terms of human behavior and not just recycling, because everyone does recycling. And the problem with recycling is that most of the materials are 100% recycled, but why do we only in the industry recycle about 9 to 12% of material? And that's because of, well, number one, it's because we value plastics too little. If you look at the value of plastics, you actually have to spend more money to convert old plastics into new plastics, right? You have to expend energy and you have to reprocess them. So it's cheaper to just use new plastics, and that's why they just continue to use it. So that's one problem, and it's human behavior. I mean, if we made the material more valuable, let's say, I mean, I'm exaggerating, but if we made plastics as valuable as platinum, you wouldn't see any of these problems, because people wouldn't leave them in the garbage. They would be collecting them. So I think we need to rethink how we utilize materials. In this case, your question was about what happened to all that other stuff they've already produced, right? Now, I would say that for many different types of food, hermetically sealed containers are actually pretty good. But just specifically for vegetables and fruits and vegetables, because they are still a live commodity in terms of food, you have to treat them this way. So it was more specialized specifically for that food group. It's interesting because before this lecture, I took a tour of your medical department or dentistry, I think. And I saw on one of the doors, microbiological area. And we actually had that capability as well, because we didn't only have designers, we had also material scientists working in our laboratory, and we had microbiologists, but not from a dentist point of view, but from a food point of view, right? Because you had to make sure that the food was able to be still eaten in a healthy way as well. So we were measuring bacteria, we were doing all of those tests as well. So you can look backwards. It is always a dilemma for a company that if you come up with new information and it supersedes everything you've done in the past, how are you going to explain that? It's there's no good answer, but the fact is that you have to explain that this is a new application of technology, and then you go from there.
Thank you.
First of all, thank you very much for your very interesting presentation and for being here with us. Looking at your presentation, first I came from my point of view, where I have been working on innovation since I graduated, but in the field of earthquake engineering. And because we live in Balkan country, the first question was always, will it be affordable? So the science on one side versus the research for the market. And even when we did the patent and it was very successful and it was a project funded by the Innovation Fund and World Bank, it's still when it reached the companies and, to have major implementation, the problem was, well, we know how much generally building a structure costs. This will disrupt that, as you mentioned, the disruption point, and we hit kind of a wall. So regarding your products, they look, you have done a lot of research, a lot of in detail kind of knowledge input from all sorts of resources. However, my question remains, are they affordable for second world countries, for third world countries, especially cities that are very dense? They're usually not very rich, they're on the poorer side. So how do you approach your research regarding how affordable these products are going to be and reaching different parts of the world, not only North America or Western Europe and so on? So that would be my question.
Okay, thank you for your question. Normally, for every product category, we would have levels of affordability. So typically there would be more, I don't know what we would call it, commodity level products that everyone can afford. And then you start charging for additional benefits. If it can do more, typically it's worth more as well. I'm not in sales, but but we do work with our marketing team in order to find the right price point. The important thing, again, is that we can never make enough product for everyone who wants it. Everything that we had planned, let's say, we would never go and industrialize without having a forecast of already a few million pieces that we would launch with, right? I mean, if it was much less, then you start to wonder whether making that product is worth making it. Because the company still has to make some money in order for it to be profitable and for it to be worth their while. So sometimes we have that dilemma even more than just our common products. I showed a product for water filtration, and this product was very special because they used this new technology. So it was actually very expensive. I had to go back to the country markets and say, I can do what you want, but it's going to cost you a lot of money. And so they asked me, well, what do you mean? What's a lot of money? And I said, it's going to retail for like $1,000. That water filter retailed for $1,000. It's not a lot if you are comparing it against like the automotive industry for cars. It's only a little bit of money, but for normal Tupperware, it's a huge amount of money. People are not used to spending this much money on Tupperware. But what happened was one of the countries, Malaysia, basically said, you know what, let's give it a try. We want this product. I said, okay, I need a forecast from you. They came back and they said 2,000 the first year. Now 2,000, normally we wouldn't even start planning anything. It's too little of a forecast. But at the same time, at $1,000 each, right? It's a $2 million piece of business. So, I talking with senior management, the agreement was, let's give it a try. So we built it, and every year they've outsold it because water is a big issue. Everyone needs access to water. Now, there are other water products on the market as well, so other people could buy maybe more affordable solutions. But this one, I'm just going to explain, outsold every year, up to the point where they were selling more than 100,000 units a year by the time I left Tupperware. So suddenly one product out of the thousands that they sell is $100 million worth of business. So sometimes you can create this through innovation. It doesn't solve the problem that you mentioned with making it affordable, but we couldn't produce enough anyway. So I think people have to make some choices in terms of what they purchase.
Thank you very much for your answer.
Any other questions? Oh.
Hi, thanks for the presentation. My question is about the solution way of the wide variety of areas. You provide us in your presentation optimum solutions. My question is the logic behind to solve the problems. Do you approach like a trees management problem solving solutions? Maybe a Russian problem solution technique, trees. How I say? I want to learn the algorithm of your problem solving mechanism.
Did you mention trees?
Trees.
Yeah. So we also use trees. So trees is a Russian methodology. I find it to be very useful because it assumes that anything you are inventing has been already invented in the past. So, why not look at what has been done? It could be already close to your solution, and then you could, leverage that. So we use a number of different methodologies, but trees is one of them.
Thanks.
Yeah, thanks.
One more question. You mentioned the disruption when you are making a product, and of course there should be disruption in the market so you can sell the product, because everybody need to understand it so they can buy it. So is there any example where you have failed with some products?
So yes, we have. Sometimes you fail because of different reasons. Maybe you do the right thing, but we follow the lead a lot of the times from our markets. Our markets should know their customers intimately, and we do research with them. And sometimes they ask for things that maybe are not well defined, and in that case, we have rushed projects to market where when the product was presented, suddenly there's no market for it, and so that's a failed product. We've done that. Let's see. One example is that we have a food storage system called modular mates. These are containers that hold dry food storage, and they come in different heights so that you can stack them and they all make sense in your cupboard. So the markets asked for a new one because it had already been 10, 15 years old, and normally there's a life cycle that you go through the product, just like a car. You want to introduce a new one. And it's very expensive to do it because you have all of these different sizes, which means you have to have all of those different molds to make them work in order to make the system, right? The problem is that they sold so much of the old one that when the new one came to market, no one wanted it. They wanted the old one because they wanted the ones that fit with the system they've already bought. This is a problem. That's one example.
Thank you.
I think this will be the last question that we will be taking for now.
Okay.
So,
Okay, thank you so much for your presentation, first of all. My question is regarding, in the last project that you presented in the water filter, you talked about the ceramic that you use to filter the water. To arrive to the solution of as I know, you worked with the porosity of the ceramic to absorb the particles that you wanted to. To arrive to this solution, how do you connect the product design with the materials research to get to this point? Yeah.
You always have to take a multidisciplinary approach, meaning that you have to match the technology with what you're trying to design. And the ceramics, by the way, was not absorbing the materials. It was preventing it from going through it worked like a grid with small nano-sized holes. And the benefit of this one was health. You didn't have to introduce any chemicals to kill bacteria or any pathogenic activity in the water. I would say that we learned a lot because from a design point of view, what we found is that the technology was so good, it filtered the water and it took out all the bad stuff, but it also took out the good stuff. So we had to actually redesign the unit so that in the outflow where the water was coming out, the clean water was coming out, we put an enhancement tank back in so that we could recollect the minerals again, right? Because the same filter took out not just the bacteria, but it took out all the minerals, and you need the minerals for health. So there's only one substance based on our research that actually exists today. It's called this Bahukan rock. It's actually certified by the Japanese government as a as a mineral that can be introduced back into drinking water. So we ended up designing the outflow with an enhancement tank to put the minerals back in the water before people would drink it. You know, so again, this is design working with the technical side. Originally, we didn't have this outflow enhancement tank. We had to put it back in because we wanted the maximum healthy situation.
Thank you.
Thank you, everyone. I would like to invite the Vice Rector. He will give to would like to thank everyone for coming to this open lecture, and I hope this was as entertaining for you all as it was for all of us. Thank you again, and see you in another environment and another lecture. Thank you.
Well, there's a will